Hello and welcome! My name is Jonathan Burnside, and I'm here to give you a quick function pointer review. If you find function pointers a little daunting or scary, hopefully at the end of this short review we can get to a point where you at least find them a little less scary. Yeah, less scary. That's a good goal for today. Let's dive right in. Here on this first slide, you're going to see three main lines of code. I know there's some comments in between, but there's really only three lines of real code going on. So I'm going to refer to them as 1, 2, and 3 to make sure we're all looking at the right spot. So on line 1 of code, we have a function declaration. We're declaring a function called foo. It returns void. It takes void as a parameter, and well, it does void or nothing. It's not a very interesting function. Not what we're here to talk about, really. On the second line, I'm making a function call. Just calling foo, and I provide parentheses at the end. That's how we make a standard function call. Still, all should be hopefully really standard. Nothing interesting is going on just yet. But let me draw your attention to the bottom line, where I am simply have typed foo and a semicolon. There are no parentheses here. This is actually how we could get the address of the foo function, or really a pointer to the foo function. So just leaving the parentheses off gives us the address. Hopefully you see the implication is that adding the parentheses is how we dereference the pointer. So any function, if we just have its name, that is a pointer to the function. When we make the function call by adding parentheses, that's when we are dereferencing that function pointer. So, if we were in class, I might ask everybody to raise their hand if they regularly use function pointers. And a lot of the class would probably not have their hand up. And they'd be wrong. We all regularly use function pointers. Every function we call, we are dereferencing the address of a function or a function pointer in order to make that call. Here on the next slide, we've made some new changes. We still have our foo function declaration, and it hasn't changed. But on the second line, we are declaring a function pointer called bar. This function pointer can point at any function that returns void and takes in void. But notice, we're not doing any initialization yet. If we look at the very last line of code, we are calling the bar function. We are dereferencing the bar function pointer and calling the function at that location by adding the parentheses. Since we've not initialized the bar function pointer, it's just pointing at uninitialized memory location. We don't really know where that's going to be for sure. It's almost certainly not going to be pointing at any particular function we would want. So no good business is going to happen when we dereference that bar function pointer. In fact, we're likely going to crash. Here's a very similar example. We have the foo function declaration followed by the bar function pointer declaration, which we've now initialized as well. We are just initializing it to a null memory address. Nothing wrong so far, but the third line, where we call and dereference the bar function pointer, that is still going to crash like the last example. This might be a little more straightforward though now, because we know bar points at null memory, and hopefully we all know we shouldn't dereference null memory locations. Compare this to, say, an integer pointer. If we make integer pointer Bob, set Bob equal to null memory address, if we then dereference Bob, we're not going to get a good result usually. Here we fixed the previous example. Again, we have the foo function declaration followed by the bar function pointer declaration, and this time we're initializing it to foo. Remember, any function's name without parentheses is its address. So this second line of code is actually real syntax for how we could declare a function pointer and initialize it to point at a particular function, in this case, foo. Now on the bottom line, when I dereference the bar function pointer and make that function call, I'm actually calling the function that bar points at. We know that will be foo. So this last line of code is actually running the foo function. Here we've made a slight change to the original foo function declaration. I've changed the parameters from void to take in a single integer. It's a bit of a side topic, but you might notice that I don't give that integer a name. This is not a syntax error. This should compile. As long as I don't use that integer inside the scope of the function, I don't technically have to give it a name. So this function declaration with the int parameter and no name should compile. You're welcome to add a name there if it makes you feel more comfortable though. What's more interesting is the second line, where we're trying to declare the bar function pointer again and initialize it to foo. The line of code we have here will not compile. The signatures between the bar function pointer and the foo function do not match. When we say signature, you might want to think type. It's a similar problem. If we tried to set one object type equal to a different type of object, and they didn't have an assignment operator between them, we would have a compiler error. And that's kind of the case we have here. These signatures must match in order to do this sort of assignment. A function signature is defined by its return type and all of its parameter types. So, in order to set the bar function pointer equal to the foo function, they must have the same return type and all the same parameter types. On this slide, we have fixed the previous error. The foo function still takes in an integer. On the second line, where I create the bar function pointer, it also expects an integer as an argument. So this second line, where I initialize bar equal to foo, that will now compile. But on the third line, where I try to call bar, as I have done previously, this will actually now cause a compiler error. Hopefully what the issue is really obvious, but if not, think about, what does bar point at? It points at the function foo. So when we try to dereference bar and call that function, we're really calling the function foo. The function foo takes in an integer as a parameter. So we are trying to call foo, but not passing it the correct parameters. Here on the last slide, we've made that very minor adjustment to the last line, in that now when we dereference the bar function pointer and call foo, we're actually passing it the expected integer argument. So everything should compile and work now. This has been fairly brief, but I hope it gives you a better understanding of how function pointers work. A couple things I want to make sure you remember. All functions, the name of the function is their address. So anytime we've called a function, we're actually dereferencing a function pointer in order to make that function call. Also, when we do an assignment of a function pointer to another function's address or location, the signatures must match. So all the return type and all the parameters must be the same for that assignment to work. An extra tricky issue you may run into is if you want to create a function pointer to a class member function. This can be extra tricky because there's another extra parameter for all member functions that we don't often think of. It's the invoking object, the this pointer. That is passed as a parameter, so that is part of those functions' signature, and will make making function pointers to them outside of that class a little trickier. Typically speaking, you're probably going to want to avoid that where you can. Make a static function in a member, or don't use member functions for function pointers if possible. It can be done, but it's a little trickier, so good luck!